Hello, engineering fans. I'm going to show you in this video how to make a program that collects data and then stores that data to a file, specifically so that we can then open that file in FreeMat and use all that great FreeMat slash MATLab analysis for our data. So in this video, I've made a car that just has an ultrasonic sensor off the front of it, and I pointed it at a wall, and I'm just going to drive that thing straight at a wall. I am going to make it accelerate at a constant acceleration so that we can see what that data looks like, that distance data. So in this, so in order to do that, I'm going to probably show you some new blocks you've never used before. For example, the ultrasonic block. Now, your EV3 software may not have an ultrasonic block. The ultrasonic block and the gyro sensor block don't come by default. You have to download those. So what you can do is just do a Google search for EV3 ultrasonic download the file, and then you go up here to tools, in block import, find that file, import it. You will have to close your EV3 software, open it back up, and then your ultrasonic block will now be there. We will also be using some of the commands from the red tab. We probably haven't used many of those, if any, yet, specifically the text, because we will be formatting our file as text, even though we're filling it with numbers. It's a text file. And so we're going to use this command to kind of build our text that we will then write to the file. And then in the blue tab, another tab we probably haven't used anything from, we're going to use this file access block right here. Okay. I'm also going to use a timer, right? So let's start with the timer actually. Let's throw a timer in there. You can have up to 8 timers timing, and you can start them over again at any point in your software with the reset. So it starts counting at that point. So I'm going to start with timer 1, resetting it right at the beginning. I'm assuming it resets anyway. I just like to do this so that I know no matter what, when my program starts, timer 1 is at 0. I'm then going to pull in my file access. Okay. Here's how the file access works. You can actually read numbers or text from a file that you can then use in your program. Or what we're going to be doing is we're going to be writing to a file that we will then get later. The file name up here, by default, they have ABC. So let's do test. That will determine what file the file name on the EV3 is. It'll be test.rtf. It's an RTF file. You can either type whatever text you want here, like "Hello world," or you can everything in EV3 is a wire, so you can drag a text. See how the square block here? That means it's a text versus the rounded means a number. You can drag a text. Like I said, we'll be using this so that you can actually programmatically control what gets written to the file. I tell you what, let's run this software right now. Maybe we'll hear the EV3. There's that noise, and that's it. The file is done. That was it. It's just super short program. It just runs right through these 2 tabs, and it's done. So now if I go to up in the tools menu, memory browser, I can see a folder for all of the projects that are currently on my EV3. There's the ultrasonic recorder. You can see I have it named up there. Here's the actual program, data collector. That's an RBF. And then here's my data file, test.rtf. Press upload to actually get it onto your computer. I feel like it should be called download, but whatever. And let's save it. And there you go. So now there it is. It's in the folder on my computer called test.rtf. I'm not going to double click it because Windows is going to open it in some weird rich text format, rich text file previewer. I just want a regular text editor. So I'm going to open it up in my Notepad++, and there it is. It's just a plain text file, no formatting at all, where the first line is "Hello World." Okay. Now, what happens if I go back and I run this program 1, 2, 3 more times? Okay. So let's go back to the memory browser. Let's scroll all the way down to find that test file, upload it to my computer. I'm just going to save right over top the old one. We're going to replace it. If I go back to my Notepad, Notepad notices, hey, that file's been changed. So let's load the new version. And there it is. You can see hello world's in there 4 times. Every single time I write to the file test.rtf, the first time you write to it, the EV3 creates the file and then writes the first line. Every time you write to the same file name after that, it just adds it as a new line. So because of that, right after resetting my timer 1, I want to delete the file. Now I'm going to call this distance data, right? I got to remember the D's are capitalized, distance data. Just in case there's a distance data to RTF on my EV3, I want to immediately delete it. That way I'm not constantly, every time I run this program, I don't want to add new data to the bottom of that file. I want to replace the old file, or even better, let's come in here and change the name every time I run the code and create new data files. So now let's get a loop in here. And I'm actually going to run this loop on a count of 100 times. And I'm actually going to use this tab right here in the loop. You probably didn't realize that. This is your loop index. Every time you go for the loop, that is a number, right? See the rounded tab? And that number goes up. So the first time through the loop, it's 0. The second time through the loop, it's 1, 2, 3, 4, and then the final time is 100. I'm actually going to, just for fun, I'm going to use that to set the speed of my motors. So I'm going to set the motors to on, going straight. I'm using the steer, which I would normally never use just because it's simple. And so now the speed, the power is going to be the index. So you're going to start with a speed of 0, then 1, then 2, then 3. So that's going to be a constant acceleration. Beautiful. Now we're ready to read our sensor data. So let's pull that ultrasonic block. My ultrasonic's plugged into port 2. It is measuring in centimeters, and this tab right here will be that number. Right now, if you look down here, I can see my port view. I'm about 239 centimeters away from the wall. It maxes out at 255, so don't be too far away. So I'm really close to the maximum distance this ultrasonic sensor can read. Notice it's jumping around. They're not, no sensors are perfect. I'm then going to pull my timer back here. This is going to be a timer read. Timer 1, same timer, but now I'm going to have this wire here to where I can read that time in. Because I want to store, I'm going to make a comma-separated values file where the first column is filled with times and the second column is filled with distances. So we're going to have a distance time graph or relationship here. So now I need to format the text that I'm going to then write to the file. So let's pull this text block. This is called a text merge. All right. So then I can say, all right, I want the first thing to be the time. I want the second thing to be a comma. So I just type a comma there. And then I can drag the ultrasonic sensors reading to the third thing. So now we've formatted a text string, time, comma, distance. Now I just want to write that to the file. So I pull our file block up, make sure I name the file the same name, distance data, and I want this to be a write because I'm writing it, and now I can drag that text wire straight in there. So every time through the loop, that's going to write a new line. This is exactly how a comma separated values file is formatted. Now, if I just hit play right now, it's going to go through the loop as fast as it possibly can, and it's going to be like done. And it's not going to be a great set of data. So let's go ahead and put a wait timer in here, and let's wait like 0.05 seconds between each time through the loop. Okay. All right. Let me just double check over my code real quick. Yeah, that looks good. I think that'll do it. All right, now I'm ready. So let's hit play. Let's drive this car straight at a wall. Look at the distance number decreasing there. Perfect. Okay, so now we've got our data. So I can go back to the memory browser, scroll down to our project folder, and there's our distance data RTF. Okay. Notice it's 2 kilobytes, whereas the test that only had hello world is 48 bytes. So definitely filled with more data. Let's save that file. Just for funsies, let's open that in Notepad and see what the format looks like. And there it is. So you can see, like, let's look at this 10th row here. 0.514 seconds in, it was 238.8 centimeters from the wall. Okay, cool stuff. It's a great set of data. 100 data points. It took about 5.627 seconds total to finish. And the last data reading was when it was 20.7 centimeters from the wall. So now let's open FreeMat. So in your file browser in FreeMat, we need to navigate to find that RTF file. It was on my desktop in a folder called engineering. There it is. Distance data. So we'll double click that and it opens it up. There's our distance data RTF. So with that window open, I can let's name the variable, the array that's going to store this information, dis. So dis equals, so we say CVS. I know it's not a CVS file, but it's formatted like a CVS. The file extension doesn't matter. So we'll say CVS read distance data.rtf, and there it is. So it is now read in as a 100 by 2 matrix, essentially, or array, 100 rows, 2 columns. So now I want to plot this. I want to see what it looks like. So I'm going to use the plot command. If we remember, the plot command works as plot a set of your x coordinates, comma, then a set of your y coordinates. So I need to be able to split this array up to just the x's, just the y's. So column 1 is the x's, column 2 is the y's. Well, whenever you have an array, you can access the elements in it with parentheses. So let's say I want to know what's the 10th, what's in the 10th row. The first number is always rows, then a comma, first column. So what's the number in the 10th row, first column? Math's telling me 0.5140. Let's double check in our text file. Let's find the 10th row, first column, 0.514. Beautiful. If I were to say second column, it should say 238.8. So now let's do a 2 here instead. Hey, 238.8. You can, if you want to access multiple items, you can use the colon. So let's say I want rows 5 through 20. So I'd say 5:20, second column. Here are the numbers that are in the second column only, but rows 5 through 20. If you don't know how many rows there are, but you want all of them, just do a colon by itself. Okay. So I'm going to say I want every single row. So colon, comma, only the first column. And there you go. That's how I access only the first column. If I want every single row, but the second column only, then I do dis parentheses colon comma 2, and boom, there they are. So I can use this to do my plot. So I can say plot. I want only the x's, so only the first column. That's dis colon for every row, but first column only. Then I say comma. Now I want the second column. So I say dis colon for every row, but second column. I hit enter. I see our plot. I love it. I love the fact that it's got errors in it. This is important to talk about as engineers. First of all, just overall, we had constant acceleration in theory, hopefully. Constant acceleration, which means the velocity was growing linearly. And so the distance from the wall, that's exactly how it should look. Exactly how it should look, that curvature. I don't want to ruin any mathematical surprises for you, but you should know exactly the name of that shape. Now you might be wondering, what is with these spikes? 1, 2, 3, 4 spikes, even some weird bumps down here. Sensors mess up. They're just not accurate. So it is your job as an engineer to come up with a strategy for either collecting your data or analyzing your data for how you can filter out those errors, those mistakes. I personally would always opt for rewriting this algorithm, adding something to this algorithm so that we can filter out the erroneous values in the data collection part of this. Okay. But I think that's a really cool result.